Going to look at transformations, and in this exercise, we'll actually bring in one other, which is a dilation. But we actually don't see it until we talk about the second function here. Now, in our first function, and we're asked to identify the parent function and then what the translation is, and then graph those. And so in this first one, our parent function is the greatest integer function. We can determine that by these double brackets here. So it is a greatest integer or a step function. And we do have a translation. It's outside the grouping symbol, and it's -4. So this is a greatest integer function with a vertical shift down. Let's write that as vertical shift down 4 units. All right, now our second one is where we actually see a dilation. So let's just briefly talk about what a dilation is. If we have in the form of a times f of x, let's say, where a is a coefficient. If a is greater than 1, we are expanded vertically. And if a is, well, I should do it like this. A is greater than 0, but less than 1, then we are compressed vertically. And if we should see that we got f of a times x, and again, if a is greater than 1, we are compressed horizontally. And if a is greater than 0 but less than 1, that should be an a, then we are expanded horizontally. Now, in that second function, g of x, we got 15 over x plus 3. Now, our parent function is the reciprocal function of 1 over x. And we can see with this plus 3, well, certainly we're going to see that we've got a vertical shift up. Three units. And this 15, this is the same thing as 15 times 1 over x, if you think about it. So a is going to be greater than 1, and then we can say that this is expanded vertically. Now, we're going to go over here and we're going to graph both of these along with its parent functions so that we can visualize what we see. So let's move over to the graph, and we'll spend just a few moments there. All right, we're over here at the graphing calculator, and first we're going to graph the parent function of the greatest integer function, our step function. And in order to do that, I'm going to first go to second math. Oh, excuse me, I didn't want to do that. I just want to go straight to math, not second math. Just go to math, and then over here scroll over to number, and we're going to choose option 5, INT. Well, I wanted to do that in y equals. Now, let's go back to math, number. Okay, option 5, finally getting it straight. Then we're going to put in x, we're going to close the parentheses. and what was that? -4. Well, no, I got this all messed up. So that's the parent function. Now I'm going to graph the transformation. So I'm going to math to the number, option 5, and we're going to go x, close the parentheses now, and -4. And let's go take a look at our graph. So in the blue, we see the greatest integer function. And we see here that at this point right here, and of every point, in fact, we see a vertical shift down by 4. And you can see why they call it a step function. It looks like a staircase. All right, let's go graph the next function that we had, the translation, that was the dilation, the stretching or the compressing. So I'm going to go in here and let's clear this. And so my parent function is the reciprocal function, 1 over x. And we're going to be graphing 15 over x plus 3. Oh. You know what? I think I want to put that 15 over x in parentheses. I wanted to make sure it's dealt with first. So I'm going to hit second, insert, put in my left parentheses, and then scroll past the x and put in that, and now plus 3. Now that 15, I think my Windows settings are -1010. And that 15 plus the 3, I'm going to change that to -20. I'm going to change both y-min, y-max, and x-min, x-max to -20, 20. And let's change the y-min to -20, 20. And y-max of 20. And let's go look at our graph. Again, the parent function is going to be in blue. The transformation is going to be in red. So there's my blue, and there is my red. I see that we've got a vertical shift up of right along this line right here, where y equals 3. And I can see that it has been expanded vertically. It's just like if you take a rubber band and you're holding both ends of this thing, and all of a sudden you pull up on that. If you can visualize that, like if you pulled up right here and over here on the right, if you had it in that way and then pulled straight up, you could say that it's expanded vertically. So now we've looked at translations, horizontal and vertical shifts. We've looked at reflections, which we also could call flips. And now dilations, where we're either expanding or compressing the graph based upon the coefficient in front of either the function or the variable itself.